Hello and welcome to the Cosmic Slumber Station, your late-night haven for unwinding under the stars. Whether you've wrapped up a hectic workday in the bustling streets of New York, or you're the type who prefers drifting off to mind-bending wonders of the universe instead of endless scrolling on your phone, this episode is crafted just for you. Settle in, let your worries fade like city lights at dawn, breathe deeply, and feel the weight of the day lift away as if you're floating weightless in zero gravity. Tonight, we're not just peeking at the night sky, we're embarking on a serene voyage through our cosmic neighborhood, the Milky Way. This immense swirling disk of billions of stars, interstellar clouds, and enigmatic dark energy has been spinning gracefully for more than 13 billion years. Yet hidden within its elegant glow are astonishing enigmas. Wandering lone wolves of stars, unseen gravitational pulls, and relics from the dawn of time that challenge everything we assumed about our place in space. We'll glide peacefully from its twisting arms to its mysterious central hub, from epic galactic mergers to stars that predate the very formation of our home. You'll discover tales of supermassive voids, birthplaces of new worlds, and the ongoing evolution of a galaxy that's far from complete. Some of these revelations might ignite a spark of wonder in your sleepy mind, or perhaps they'll simply lull you into peaceful dreams. And right before we set off, if these tranquil dives into the cosmos help you relax after a long drive on the interstate, or provide a soothing escape from everyday hustle, think about giving this a thumbs up and hitting subscribe. It guides more fellow night owls to this cozy corner of the internet, one relaxed explorer at a time. All right, let's ease into it. The Milky Way has already merged with several galaxies in the past, and more unions are on the horizon. Our starry abode might seem like a steady sanctuary, but it's constructed from the fragments of cosmic encounters. Across eons, the Milky Way has engulfed tinier neighbors, tugging them inward, disentangling their forms, and dispersing their components into flowing rivers that encircle the main body. One example, the Sagittarius satellite, is currently in the midst of being dismantled, and way out there in the evening heavens, the Andromeda spiral is inching nearer. In roughly 4.5 billion years, these two majestic whirlpools will intertwine in a grand celestial embrace. Individual stars will seldom collide, but the overall architecture will transform eternally, blending into an expansive, serene new entity. Even these vast star systems aren't forever. They adapt, fuse, and rebirth anew. Certain stars within the Milky Way predate its own existence. Not all the lights twinkling in our galaxy originated here. Some outer-ring wanderers, primordial and lacking in complex materials, seem to have emerged prior to the Milky Way's complete assembly. Scientists suspect these originated in minuscule early universes that later combined with ours eons ago. Their elemental profiles reveal scant traces of denser substances, indicating birth soon after the universe's explosive origin. They cruise leisurely and elevated above the central layer, akin to timeless guardians from an era predating organized swirls and harmony. Through their radiance, we glimpse a fresher, more chaotic cosmos still figuring out its destiny. Our planetary family circles the Milky Way's heart at exceeding 828,000 kilometers per hour. That's over 230 kilometers each second. Yet, a single circuit around this immense wheel demands about 225 million years. This cycle is termed a galactic revolution. In terrestrial terms, we've only completed around 20 such laps since our system's inception. Back when the initial reptiles roamed America's ancient lands, we occupied an entirely different sector of this star-filled expanse. The constellations visible now weren't constant companions and won't stay that way. All is perpetually shifting, subtly, gradually, without end. Even in slumber, our world rotates. The lunar companion revolves, and the whole solar setup propels onward amid a dynamic stellar sea. The galaxy continues to expand even today. Though venerable, the Milky Way isn't finalized. Presently, it accrues fresh elements. Vapors from beyond galactic borders, luminaries from ensnared minor systems, and flows of shadowy substance bolstering its outer envelope. It enlarges not organically, but as a pull-based framework intensifying across ages. Portions of this accrual occur subtly via infiltrating mists. At other moments, it's turbulent as captive companions get fragmented, their contents strewn throughout the void. The star realm you inhabit now differs from what prehistoric creatures beheld in the Grand Canyon skies, and for far future kin, it might swell further, woven from the debris of countless lesser realms. We remain uncertain about the exact count of the Milky Way's arms. It feels like basic knowledge we ought to possess, the number of curving branches emanating from our galaxy's core. However, embedded deep within its platter, perceiving the full layout proves challenging. Obscuring hazes veil remote zones, lights merge indistinguishably. For years, experts posited 4 primary helical limbs. Fresher data implies perhaps fewer, or that they branch and coil in unexpectedly intricate fashions. Some dissipate into pieces, others encircle in surprising ways. The Milky Way might not resemble a tidy wheel at all, but a vibrant, stratified vortex molded by influences we haven't fully decoded. Outcast stars get catapulted from the nucleus. The bulk of stars meander placidly through the expanse, but occasional ones are propelled externally at staggering velocities, sufficient to flee the Milky Way forever. These are ultrafast travelers. Some stem from paired setups fractured by the colossal void at the galaxy's midpoint. One partner plunges inward and dissipates, the other gets flung away, launched into obscurity at over 1,000,000 kilometers hourly. These solitary voyagers journey isolated, distant from the primary level, resembling luminous wanderers without comeback. They underscore that within a gravitationally tethered realm, eruptions of force occur, serene ejections propelling lights into the boundless beyond. The Milky Way and Andromeda are destined for convergence. Elevated in the nocturnal vista, the Andromeda counterpart manifests as a subtle smudge to unaided vision, a helix akin to ours, positioned over 2 million light-years distant. Nonetheless, it's advancing resolutely our way. In approximately 4.5 billion years, the Milky Way and Andromeda will intersect. It won't be destructive as one might envision. Lights are too dispersed for direct impacts. Yet their attractions will contort both into elongated sweeps. Gravitational extensions will spiral externally. Voids might twirl inward, and following billions of years, the duo will consolidate into a singular amplified arrangement. It will unfold as a languid, refined waltz, the destiny of our stellar dwelling inscribed amid the cosmos. Certain stars revolve counter to the norm. The majority in the Milky Way circuit the nucleus in a unified orientation. But exceptions exist. Some, particularly in the external envelope, traverse reversely, countering the predominant spin. These likely hailed from afar, spawned in minor systems subsequently integrated. Their inverted trajectory is a subtle emblem of their alien roots, as though the galaxy harbors vintage recollections in its kinetics. Narratives of primordial fusions and stellar meetings etched not in glow, but in the deliberate, enduring reversal of celestial bodies against the flow. The Milky Way might have devoured scores of minor galaxies. Through billions of years, the Milky Way hasn't matured in solitude. It has assimilated. Diminutive star clusters, ethereal associates, have neared, ensnared by its draw and progressively deconstructed. Their components now integrate into our envelope, platter, or luminous trails. Researchers have pinpointed various such integrations via examining stellar paths and makeup. One notably substantial occurrence, the Gaia-Enceladus fusion, contributed numerous lights and possibly reconfigured the nascent framework of the galaxy. The Milky Way isn't an untainted helix. It's an amalgam pieced from subdued impacts, fused from the vestiges of myriad tinier domains. The elemental composition of stars discloses their birthplace. Each star bears a distinct elemental signature, a blueprint of substances embedded at genesis. By scrutinizing these markers, experts can unravel a star's lineage. Some abound in denser components like iron and calcium, implying formation in compacted, substance-laden areas. Others are almost solely hydrogen and helium, originating when the cosmos was nascent. These variances enable grouping stars into lineages, unveiling primordial integrations, and reassembling the concealed chronicle of the Milky Way's emergence. Thus, elemental science turns into a temporal portal, allowing us to interpret a star's heritage like verses of archaic verse inscribed in radiance. The heavens brim with luminous trails from fragmented galaxies. Throughout the firmament, slender bands of stars extend in bows and bends, scarcely perceptible, yet distinct when charted accurately. These are luminous trails, the leftovers of lesser galaxies that ventured too near the Milky Way and were shredded. As they circuit, their stars get smeared by attractive forces, creating elongated, fragile paths that outline their prior routes. Some envelop the galaxy like spectral auras, others plunge toward the nucleus. These trails testify to former intersections, serene fusions that constructed the Milky Way over eons. The galaxy, akin to an ancient tree, bears the circles of its history in every strand of glow. The Milky Way exhibits a curvature. Our galaxy doesn't rest level like an ideal helix. Its platter curves upward on one flank and downward on the opposing, crafting an elegant undulation amid the stars. This mild distortion evaded notice until wireless observatories charted the hydrogen vapors extending well past the stellar shine. Experts theorized the aberration could stem from companion galaxies subtly yanking the Milky Way's boundaries, or from aggregations of shadowy substance warping the form from beneath. Resembling ripples in an immense rotating canvas, the curvature discloses that even star systems are perpetually restless. Across durations, they flex, bend, and alter silhouette in reaction to concealed influences. From afar, the Milky Way could appear to be swaying leisurely across the void. With bare eyes, you perceive merely about 305% of the Milky Way. Beneath a pristine, unlit sky, distant from urban glow and highway lamps, you could spot several thousand stars. To human sight, that feels like a sea of brilliance, but it's hardly a speck. The Milky Way encompasses over 100 billion stars. Most elude observation. Some hide behind dense shrouds of particles. Others are too dim or remote for our perception. The faint band of the Milky Way traversing the sky on lunarless evenings is merely the innermost murmur of the entirety. We exist encircled by a monumental torrent of stellar radiance, yet nearly all remains concealed from us, too expansive to comprehend from inside. Stars circuit the galaxy at varying paces. Unlike worlds in a solar arrangement tracing orderly routes around their central light, stars in the Milky Way exhibit greater liberty. Some dash forward in internal zones, others lag in the peripheries. This pace disparity is why helical branches emerge. They're not rigid formations, but configurations akin to gradual congestions of stars and vapors traversing space. As these compression surges advance, they initiate fresh star births, illuminating the branches in sweeps of azure and ivory. Our own central star participates in this eddy, entering and exiting these formations over epochs. The galaxy isn't a timepiece, it's a stream, and we float within it. The galaxy coheres due to an undetectable element. Logically, the Milky Way shouldn't persist. From observable metrics, stars, particles, vapors, the external fringes spin excessively swiftly. They ought to scatter outward like foliage in a gale, yet they endure. The solution is shadowy substance. This enigmatic material neither radiates, mirrors, nor releases any glow. But it applies attraction, and its abundance surpasses all visible components manifold. We lack knowledge of shadowy substances' nature, but without it, the Milky Way would disintegrate. It's the unseen framework sustaining all. There's a colossal void at the nucleus. In the absolute midpoint of the Milky Way resides a tremendous gravitational sink, a pinpoint dubbed Sagittarius A. It exceeds 4 million solar masses, yet it spans less than Mercury's circuit. Direct visibility eludes us, but we've observed adjacent stars hurtling around it at immense velocities, sketching unseen rings in the emptiness. Occasionally, vapors and particles descend inward, erupting in high-energy beams as they coil into the boundary. Presently, Sagittarius A slumbers, but in antiquity it might have blazed like a brilliant beacon, illuminating the galaxy internally. It serves as the muted orchestrator of the Milky Way's core, drawing stars into a gradual, unyielding ballet. The Milky Way features a nut-like central swell. Upon charting the galaxy's midpoint, researchers uncovered an anomaly. The inner swell isn't a uniform spherical cluster of stars, but a tridimensional nut contour. Viewed laterally, it expands centrally and tapers at extremities like a contorted sand timer of lights. This peculiar outline probably arose from the galaxy's inner rod, a compacted band of stars rotating languidly, buckling and inflating upward across time. These core formations are carved by attraction, eons of kinetics, and the amassed cadence of stellar circuits. We dwell in a helical galaxy, but its essence brims with intricacy, not planar or pristine, but elaborate and vibrant. Star cradles define the helical branches. The Milky Way's helical branches aren't merely composed of stars. They're interlaced from star origins. Colossal accumulations of hydrogen, particles, and compounds wander the galaxy. When these accumulations traverse the helical branches, they compress and ignite with emerging luminaries. These areas are star cradles, tumultuous, radiant, and kinetic. High-frequency rays from nascent stars illuminate the accumulations, adorning the branches with vivid blues and silvers. These creation surges delineate the helical form, highlighting the galaxy's arcs with subdued blaze. Every star, including our Sun, emerged from such misty nurseries ages past. The Milky Way is encircled by an expansive envelope. Past the broad helical platter extends something vastly more scattered, a globular envelope enveloping the whole galaxy. It harbors vintage stars, dense star balls, and immense quantities of shadowy substance. Though nearly unseen, this envelope might contain the bulk of the Milky Way's weight. Its stars are thinly distributed over huge spans, circuiting in extended, gradual bows that seldom intersect the platter. The envelope also safeguards vestiges of primordial galactic fusions, trails and casings of stars extracted from lesser galaxies and abandoned like stellar artifacts. It is the galaxy's external archive, subdued and faint, yet still kinetic, still molding what the Milky Way evolves into. It harbors over 150 dense star balls. Dense star balls rank among the galaxy's eldest entities, compact orbs comprising hundreds of thousands of closely linked stars. They circuit the galactic midpoint in the envelope like insects encircling a remote blaze. These balls are remarkably enduring, some surpassing 12 billion years, and many enclose stars antedating the Milky Way proper. Their stars lack dense elements, signifying formation before the cosmos produced abundant heavier substances. They function as temporal vessels, containing hints to the galaxy's assembly, its absorptions, and early cosmic conditions. These serene golden orbs wander calmly above and below the galactic level, shimmering in obscurity. The galaxy is still expanding. Though venerable, the Milky Way isn't complete. Even now, it accrues material. Vapors from beyond galactic confines, stars from seized minor galaxies, and streams of shadowy substance nourishing its envelope. It enlarges not biologically, but as a attraction-based edifice deepening over durations. Some expansion transpires subtly via permeating mists. Other instances involve upheaval as satellite galaxies fragment, their stars dispersed across the heavens. The galaxy you reside in today differs from what ancient beasts witnessed in the Rocky Mountains, and the one your remote offspring might experience could be grander yet, pieced from the remnants of 1,000 lesser domains. Outcast stars get catapulted from the nucleus. The majority of stars meander placidly through the galaxy, but rare ones are propelled outward at staggering velocities, enough to escape the Milky Way forever. These are ultra-fast travelers. Some are leftovers from paired setups disrupted by the colossal void at the galaxy's midpoint. One partner descends and vanishes, the other is flung away, launched into obscurity at over 1,000,000 kilometers hourly. These solitary voyagers journey isolated, distant from the primary level, resembling luminous wanderers without return. They underscore that within a gravitationally tethered realm, eruptions of force occur, serene ejections propelling lights into the boundless beyond. Star birth is decelerating. Ages ago, the Milky Way buzzed with activity, teeming with emerging stars from compacted, imploding mists. But lately, the tempo has eased. Vapors remain available, but much is diffused, warmed, or trapped in resistant forms. The galaxy hasn't ceased producing stars, but it's calming. Experts gauge that star birth crested eons past and has waned since. This doesn't signal imminent conclusion, merely that we exist in a milder phase. A seasoned helix radiating softly in its maturity, still birthing stars, but without haste. Certain stars emerged before the Milky Way possessed a platter. The platter, the expansive flat helix we envision as the Milky Way, coalesced progressively over time, but some galactic stars outdate the platter itself. These vintage lights mostly dwell in the envelope or thicker platter, forming when the galaxy was aggregating, a lax aggregation of stars, vapors, and shadowy substance gradually contracting inward. By examining their makeup and kinetics, researchers can gaze into the period before organization, before helices. These stars are the galaxy's seniors, mute observers to its genesis and the extended, gradual sculpting of our abode. A galactic revolution spans about 225 to 250 million terrestrial years. As the Sun circuits the Milky Way's midpoint, it finishes one complete loop every few 100 million years. This is a galactic revolution, an immense kinetic cycle dwarfing all calendars. In the span for the Sun to encircle once, landmasses shift, life forms ascend and decline, and whole eras transpire. It's believed we're midway in such a circuit. The prior occasion the solar setup occupied this segment, the superlun Pangea was fragmenting, and reptiles hadn't arisen. A galactic revolution is the leisurely pulse of the Sun has finished fewer than 25 galactic circuits. Across its 4.6 billion years, the Sun has looped the Milky Way merely around 20 times. That's less than anticipated given its tremendous pace, nearly 830,000 kilometers hourly. But the galaxy's immensity and the Sun's extended route mean each loop demands hundreds of millions of years. We frequently view stars as timeless and static, but our solar setup is youthful on galactic scales, a novice in a metropolis of elder, more traversed lights. We partake in the galaxy's kinetics, yet early in its winding narrative. The Milky Way's spin defies classical forecasts. Per Newtonian principles, stars distant from the midpoint should circuit slower, akin to outer worlds leisurely orbiting the sun. But in the Milky Way, peripheral stars revolve nearly as swiftly as central ones. This contradicts traditional anticipations. The cause, researchers posit, is shadowy substance, an unseen, unidentified mass form encircling the galaxy in a vast envelope. Absent shadowy substance, the galaxy wouldn't cohere. With it, calculations align. The Milky Way rotates like a unified disk, not due to full comprehension, but because something concealed anchors it. The galaxy boasts colossal compound clouds. Dispersed through the Milky Way are immense, shadowy vapor accumulations, the foundational stuff of stars. These compound clouds, chiefly molecular hydrogen with particle traces, can extend hundreds of light years. Inside their chilled, compacted cores, attraction assembles material, forming lumps that implode into fresh stars and worlds. Some clouds are so vast and frigid they fully absorb visible glow, appearing as ebony voids against starry backdrops. They are the galaxy's birth chambers, subdued, concealed spots where tomorrow commences in hush, nestled in veils of shadow and vapor. Stellar explosions agitate the galaxy like tempests. When hefty stars conclude their spans, they detonate in catastrophic blasts. Outbursts so potent they momentarily eclipse whole galaxies. These blasts don't merely terminate existences, they engender. Compression fronts from explosions propagate through surrounding space, squeezing nearby accumulations and sparking fresh star birth waves. They infuse adjacent areas with denser elements like iron and gold, created in the expiring star's core. Thus, explosions function as tempests in the galactic habitat, stirring, enriching, and reconfiguring surroundings. They are the galaxy's chaotic instants, ruinous, luminous, and essential. Particles conceal extensive star birth zones. The Milky Way teems with unseen radiance. Interstellar particles, microscopic specks of carbon, silicate, and frost, interlace the galaxy in accumulations and strands. Invisible glow, they eclipse broad swaths, erasing stars and whole glowing clouds. But behind this barrier, star birth persists. Heat-sensing observatories penetrate the particles, unveiling sparkling cradles brimming with infant suns. What seems obscurity often cradles. The particles, though obscuring, participate, absorbing power, cooling vapors, and protecting nascent stellar phases. Apparent void frequently heralds brilliance. There exist vapor accumulations without stars wandering the galaxy. Not every vapor accumulation births a star. Throughout the Milky Way, researchers have identified hefty chilled accumulations seeming primed for implosion, yet staying dim and inactive. Some are overly sparse, others stabilized by magnetic influences or inner churn. These starless accumulations float like mute potentials, abundant in molecular hydrogen but unfused. They might eventually spark or wander until disrupted by outer forces, their vapors repurposed elsewhere. In these accumulations, the galaxy pauses, awaiting perhaps the precise impetus to ignite novelty. The Milky Way repurposes material over lineages. Stars aren't everlasting. They exist, combust, and perish. In perishing, they restore their essence to the galaxy. Explosions disseminate denser elements. Enlarged giants slew external sheaths. Gaseous envelopes drift outward. This enhanced material merges with surrounding space, chills, condenses, and ultimately forms fresh stars, worlds, and even organisms. Every particle in you has traversed this loop, spawned in a star, dispersed into void, amassed anew. The Milky Way isn't a fixed arena, but a grand renewal mechanism. It inhales in sync with its stars, creating, dismantling, and recommencing. Substance-scarce stars offer insights to the primordial cosmos. In stellar studies, substances mean elements beyond helium. The cosmos's earliest stars possessed nearly none, forming before prior star generations forged and scattered them. Today, researchers hunt substance-scarce stars in the Milky Way's envelope. These dim vintage lights preserve antique chemical states. By dissecting their makeup, we peer into the original era, post-universe origin, before galaxies ripened, before our galaxy fully shaped. They are glowing relics. Some stars stray distant from birthplaces. A star's origin doesn't invariably dictate its fate. Over durations, many drift from natal accumulations, nudged by attractive interplays, circuit harmonies, or gradual helical branch tugs. Some get ejected swiftly, hurled across the platter or into the envelope. Others migrate steadily, adjusting circuits inward or outward amid galactic twirls. Even our sun isn't at its genesis. Mapping stellar routes reveals a Milky Way far from inert, a realm vibrant with exchange, shift, and subtle relocation. A star's abode may be transient. The galaxy's livable band might extend tens of thousands of light years. Just as Earth circuits in a temperate zone around the Sun, not overly scorching or frigid for existence, the Milky Way may feature its own galactic temperate zone. This area is believed to reside between the perilous inner hub, rife with energy bursts and attractive turmoil, and the barren substance-scarce outer rims where worlds form less readily. Midway lies a broad swath where stability prevails, star crowding is moderate, and elements like carbon, oxygen, and iron abound. Earth resides herein, one serene circuit in an immense eddy where existence might not be solitary in establishing roots. The helical branches aren't static formations. The Milky Way's helical branches may appear enduring traits, majestic sweeping curves etched into the platter, but they aren't composed of fixed stars. Rather, their patterns, compression surges rippling leisurely through the platter, squeezing vapors and initiating fresh stars upon passage. Stars enter these branches, radiate briefly, then exit. The helical framework moves differently from stars, like a congestion advancing on a freeway. From distance, it seems structured and orderly. From inside, it's a kinetic interplay sustained by attraction and duration, never static, perpetually streaming. The Milky Way resonates with stellar energy. Beyond visible glow, the galaxy radiates in enigmatic energy forms. High-velocity particles, born in explosions and remote galaxies, surge through space and traverse your form each second. High-energy beams and intense rays emanate from perishing stars and voids. Wireless signals drift from vapor accumulations, spinning remnants, and chilled hydrogen exhales. These unseen resonances unveil what glow cannot. The ferocity, attraction, and vintage fires lingering in the galaxy's framework. Gazing at the nocturnal sky reveals only a slim segment of the Milky Way's authentic range. Beneath the stars, the galaxy hums gently in myriad hues, myriad vibrations, a concealed harmony in obscurity. There's an immense high-energy lobe above and below the nucleus. Extending tens of thousands of light years over and under the galactic midpoint are two vast ethereal lobes of intense glow. The Fermi lobes, recently uncovered, they shine in high-energy rays, protruding like dual inflatables from the Milky Way's essence. Origins remain unclear. They could be leftovers from an antique surge from the central void or imprints of vigorous star birth once blazing the hub. Regardless, these colossal formations drift silently above the galaxy, unseen to bare sight. They remind that the Milky Way harbors an unseen history, reverberations of force enveloped in splendor far over familiar stars. We occupy a lesser extension between primary branches. Our solar setup doesn't reside in one of the Milky Way's principal helical branches. Instead, we inhabit a minor formation called the Orion Extension, a comparatively serene pathway of stars situated between the grander Sagittarius and Perseus branches. It's not particularly crowded or active, but that might explain our presence. In the tranquility amid galactic thoroughfares, hefty explosions are scarcer, energy tempests less common. This subdued nook may have granted Earth's life the duration to arise and develop. From peripheries, the galaxy appears vivid and dynamic, but in this calm extension, we discovered sufficient serenity for intricacy to emerge. The Milky Way has a rod-shaped nucleus. When researchers gaze toward the galactic hub in heat glow, they observe not a flawless circle, but a stout elongated rod of stars spanning the middle, a sort of radiant connector. This rod rotates gradually, its attractive influence molding the inner helical branches. Such rods are typical in helical galaxies. They emerge when platter stars drift inward and accumulate along a central line. Over time, the rod stabilizes, agitating vapors, sparking fresh stars, and channeling material to the central void. It's not merely a contour, but a kinetic driver, sculpting the galaxy's essence internally. It's part of a broader assembly called the nearby cluster. The Milky Way doesn't stand alone. It belongs to an assemblage of over 50 galaxies termed the nearby cluster, a modest grouping drifting collectively through void. The two largest are the Milky Way and Andromeda, each with satellite families. Around them scatter lesser dwarfs, dim ovals, and substance-poor galaxies nearly wholly shadowy substance. The nearby cluster spans over 10 million light-years, bound not solely by closeness but by attraction. We integrate into this kin, sparsely spaced yet connected by unseen strands of shared kinetics and reciprocal draw. Galaxies in the nearby cluster are attractively linked. Despite immense gaps, the nearby cluster's galaxies aren't diverging. Many inch toward each other. Attraction maintains them in a leisurely celestial dance, arcing paths over millions of years. Some tiniest galaxies circuit the Milky Way like satellites, looping, descending, dissolving into trails. Others wander autonomously but tethered, ensnared in a kinetic web. Over durations, this cluster may compact. Galaxies might fuse, diminish, or integrate. It's not fixed, but a mild convergence of stellar isles, a kin drawn nearer by duration, momentum, and attraction's extended grasp. The galaxy's platter has thick and thin layers. The Milky Way's platter appears level from afar, but closely it's stratified. The thin layer is our home, a broad, crowded plain with youthful stars, loose groups, and birth vapors. But over and under lies the thick layer, elder, more inflated and scattered. Thick layer stars are typically older with fewer dense elements. They traverse more inclined, oval paths, suggesting formation under alternate conditions or agitation from early galactic impacts. The platter isn't uniform, it's textured, layered, shaped by time like deposits on a stellar ocean floor. The galaxy's attractive field weaves through the platter. Though unseen, the Milky Way is threaded with an immense attractive field extending across the platter, ascending into the envelope and interlacing surrounding space. This field is feeble by terrestrial measures, but over galactic spans, it molds cosmic particle travel, accumulation collapse, and material flow. It aligns with helical branches, arcs over the plane, twists into inexplicable loops. Studying requires wireless observatories and meticulous analysis, but its existence is evident. The Milky Way doesn't solely radiate glow. It pulses with attraction, a subtle rhythm through its structure. Surrounding space isn't vacant. It's a churning ocean. Interstellar space isn't uniform or still. The surrounding medium, a dilute mix of vapor, particles, and charged gas, is stirred by compression fronts, attractive fields, and stellar kinetics. Heat varies wildly. Material streams collide, blend, fragment. Accumulations extend, fold, tumble. On grand scales, this generates turbulence like a gradual sea eddying the platter. Star birth, cosmic particles, and galactic development are influenced by this restless ocean. What appears calm starshine from distance is closely a kinetic, undulating fabric shaped by concealed currents and vintage power. Cosmic particles perpetually traverse us from the galaxy. Each second, high-velocity specks, mostly cores and nuclei, surge through you, propelled ages ago by detonating stars. These are cosmic particles, ubiquitous. They near light speed, curving through attractive fields, rebounding off accumulations, occasionally impacting atmospheric particles, generating secondary cascades. Usually unnoticed, they bear tales from galactic spans, proofs of antique detonations, hints of remote acceleration, dispatches from stellar violent cores. Even resting, the galaxy murmurs in specks, in hush, in glowless beams. The galaxy isn't balanced, though illustrations often depict it neatly helical. The Milky Way lacks perfect equilibrium. One platter side seems denser. Some helical branches are brighter, extended, or more arced. The outer platter curvature is uneven. Even stellar counts between halves differ slightly. These imbalances may arise from attractive meetings, prior fusions, or shadowy substance influences. They remind galaxies, like organisms, bear historical traces in forms, collision marks, temporal creases, and growth quirks, adding personality and profundity. The eldest identified star might reside in our envelope. High over the galactic level, wandering the envelope, researchers found a star potentially nearing universal age. It holds nearly no dense elements, a mark of stars born post-universe origin before supernova enrichment. It likely formed over 13 billion years past, pre-Milky Way full formation. It glows softly red now, low mass but history-rich. It's not merely a star, it's a temporal vessel, a vibrant artifact from the cosmos's initial dawn. The nucleus spins swifter than peripheries in the Milky Way's inner zones. Stars circuit the midpoint far quicker than distant ones. Near the hub, attraction intensifies, dense with stars, particles, and Sagittarius A. This prompts stars to trace tighter, faster loops, completing in mere millions of years. In galactic outskirts, like our sun's locale, stars circuit slower, taking hundreds of millions. This uneven spin creates twisting configurations, extends helical branches, prevents platter-solid behavior. The galaxy moves like a grand wheel whose edge trails its hub. Helical branches form via compression surges. The Milky Way's helical branches aren't fixed star paths. They're configurations from higher density, surges through the galactic platter. As vapors and particles pass these surges, they compress, triggering star birth and brightening branches with youthful lights. These stars eventually exit the surge as new form behind, sustaining the structure illusion. Like pond ripples or freeway crowding, branches are kinetic, perpetual motion. From afar, static. From within, matter and rhythm dance, shaped by attraction and duration. Stars birth from chilled, imploding vapor. In the Milky Way's dim branches, star formation starts silently. Vast molecular hydrogen accumulations, sometimes hundreds light-years wide, wander void, cooled near absolute zero. Within, attraction gradually dominates. Regions densify, collapse under weight. Falling vapor heat spins, flattens, forming a nascent core. Pressure and heat rise till fusion sparks, birthing a new star. From deepest shadows emerge brightest glows, gently woven by attraction's subtle force. Star groups can disperse into galactic fields. Many stars birth grouped, not solo. Dense groups from identical imploding vapor cloud. These groups, gravity-bound, wander together millions or billions years, but time scatters them. Galactic attractions, stellar meetings, inner dynamics pull apart. Stars detach singly till the group fades into general starscape. Even our sun likely birthed in such a group ages ago. Its kin now scattered, dimmed, lost in distance haze. The galaxy holds vintage ultrasubstance scarce stars. Among Milky Way's rarest treasures are ultrasubstance scarce stars, atmospheres with nearly no elements past helium. Some hold less than 1/10,000th solar iron, believed post-first explosion births bearing faint early universe enrichment, incredibly aged, pure, scattered in envelope like dawn lanterns. Each relic glowing gravity-bound sign from near-forgotten time. Planetary setups form galaxy-wide. Planets aren't cosmic rarities, natural star birth outcomes. as new star ignites, leftover vapor particle disk surrounds. Within specks adhere, accrue, grow worlds. Milky Way brims with planetary setups, some vast with gas behemoths, icy satellites, others tight with rocky orbs near faint stars, some mirror ours, others defy. Galaxy not just stars, full of setups, stellar kin, each unique balance, circuit, potential. Earth nears the co-spin boundary. In Milky Way, helical branches rotate differently from stars, moving patterns not solids. But a special midpoint distance, co-spin boundary, matches average star pace to branch spin. Our sun's circuits near this. This motion harmony may avert frequent branch crossings, denser stars, more explosions, attractive disruptions. We possibly dwell in stabler galactic area, protected by harmony, not barriers. The sun oscillates vertically through galactic level. Orbiting Milky Way, sun follows no flat route. Instead, gentle wave, rising falling over tens millions years like slow cork, caused by galactic mass tug, pulling releasing as moves. Some speculate influences Earth life cycles, evidence unclear. Reminder. On steady path, sun sways softly. We don't sense Milky Way from Earth. Embedded, can't view Milky Way top down. See internally, flat star ribbon across sky, horizon curved. This edge view compresses into arc, hard grasping full from perspective. Took centuries observing, listing, deducing to realize our helix. From Earth, gaze along galaxy grain through richest paths. Like forest stand, viewing tree line, don't see enclosing shape, only surrounding vastness. The galaxy contains far more than perceivable. Even advanced tools glimpse fraction of Milky Way, glow blocked by particles. Kinetics hidden silently, shadowy substance outnumbers luminous, between stars emptiness, within empty potential. Milky Way not just seen, suspected, inferred, yearned understanding. Holds vintage glow, future stars, wandering worlds, unanswered queries. Amid vastness we exist, one world among many, circling quiet star, floating in too wide tail, and now stars fade behind thoughts. We've meandered hundred serene insights, from platter curvature to farthest envelope stars, newborn suns to perished remnants, particles and vapor to glow and shadow, all between. Wandered star cradles along helical branches toward galactic essence behind particle curtains. Your galaxy part, not mere Earth rider, but long luminous unfolding participant, blood iron star forged. Breath oxygen ancient blast sculpted, body atoms trace earliest from matter fueling suns, whispering interstellar particles, tonight resting, galaxy proceeds, stars forming, glow traveling, silent circuits continue. You float within small warmth in dark, resting spiral arm quiet radiant sea. If awake, proceed next chapter. Hope peaceful sleep, soft dreams, good night.